Hello and welcome back. We are going to be covering section 7.3 in this video, which has to do with square root equations and inequalities, their domains, their ranges. How do we graph them? What do they look like on a graph? So to start, you can see something of a terrible definition since it uses the term square root in the definition. But what is a square root function? It's a function that contains a square root. That's not too complicated. The parent function, kind of the most well-known, the one that we base everything off of, is just the simplest square root function you can have. Y equals the square root of x, or y equals root x. So one thing that is interesting about square root functions, we've talked at length about how whenever you take a square root, you have a plus or a minus answer. Those are the two branches of that kind of sideways looking parabola. It's a plus answer or a minus answer, plus or minus root x. But if you don't spot the problem with that, it has to do with calling this a square root function. Remember, functions must pass the vertical line test, which means if I draw a vertical line anywhere on this graph, I can't hit a function more than once. And lo and behold, here I just hit it twice. I hit that square root non-function twice. So the graph of this square root equation is not a function. So what did mathematicians do? They said, well, we'd really love to talk about square root functions. So they came up with an idea. They said, all we're going to do is consider half of it. We're not going to consider both the plus or the minus. By default, we'll consider the plus, the positive square root. And we'll just, when we're graphing them and when we're talking about square root functions, we'll ignore that bottom branch. And so that's what we're looking at here. And it says down here, y equals plus or minus root x. It's not a function. But if we only include that positive part, it is a function. It does pass the vertical line test. So this is more what we're looking at today. And I want you to look at this green graph and notice a couple things. First, while it goes forever in one direction, it definitely has a starting point or a stopping point, however you want to look at it. It doesn't go forever in both directions. Okay, that's something that's really important to know about square root functions. Also notice that this one only goes up. It's always going to be going up. It starts off kind of steep and then it levels out, but it's always increasing. We'll see some square root functions that are always decreasing. Or maybe they're decreasing going to the left, increasing going to the right. But the point I want to make here is that every square root function will only be going one direction. It's only going up, increasing, or it's only going down. And so that lets us say something about the range. The range of this function right here, well, what y values do we see on the graph? We see anything it looks like that is greater than or equal to 0. We could also write it in that interval notation from 0 to infinity, starting at 0, including it with that square bracket, going all the way up towards infinity. So that is the range of this function, and we know we're going to hit everything greater than or equal to 0 because it goes up forever. And we're never going to hit anything below 0 because it never comes down. What is the domain of this square root function on the screen? Well, the domain is the possible x values. And if you remember back in 7.1, we talked about restricting the domain. Well, we have to do the same thing here. What x values does this graph exist for? It looks like it exists for everything going this way, positive xy's, but we said it started right here. So the only x values that this exists for are those x values that are greater than or equal to 0. Now, this is not going to be true for every square root function. It's not always going to be 0 to infinity for both of those. But on this very basic parent function one, it is. It just happens that the domain is x is greater than or equal to 0, range y is greater than or equal to 0. So now that we kind of know the shape, the general shape of a square root function, Let's take a look at one of these problems. And I took this example from the book because I think it words a couple things really nicely and shows. Here's how we're going to graph and find domain and range of a square root function. The first thing you want to do is find the domain. And how do we just find that from the algebraic equation? Well, the key is right here. And I meant to grab my highlighter. Here we are. The radicand, what's under that square root sign, cannot be negative. At this point, you might be looking at me feeling a little betrayed because back in chapter 5, I told you, guess what? We can take square roots of negative numbers. They're just imaginary numbers. And now I'm telling you the radicand cannot be negative. And so it seems like a double standard. It is. It is the bottom line. When we're talking square root functions, most commonly we only talk about them in the sense of the real numbers. And so in the real numbers, we cannot take a square root of a negative because it would make it imaginary. So for right now, and it's hard to toggle back and forth between these, I know, but right now, square root functions, we're saying we're only dealing with the real numbers. The radicand cannot be negative. So how do we find the domain? We take the radicand and say it has to be greater than or equal to 0. It can't be negative. So that means if we solve this, 3x is going to be greater than or equal to -4, which means x is going to be greater than or equal to -4 thirds, and that is my domain. X is greater than or equal to -4 thirds. So how do we find it? Take the radicand, make sure it's greater than or equal to 0, and then solve for x. So we're 1/3 of the way there. We were looking for the domain, the range, and the graph. Also, this problem asks you about the x and y intercepts. We'll kind of find those along the way, but the three big ones are the domain, range, and graph. So we know the domain, and I can fill that in down here. From the domain, this is where we're going to start making our table. Okay, so we're going to find domain, then the table, then the range. So we have a table over here on the right side of the screen. You'll notice, where do we start our table? We start our table at whatever significant value we found for our domain. -4 thirds, well then that's where we're starting our table. -4 thirds we plug in for x. We can use a calculator. We can use the table function. Y is 0. Okay? Now we know that the x's are greater than or equal to -4 thirds, so then we can just start plugging in values greater than or equal to -4 thirds and kind of get an idea of what this graph should look like. As it turns out, this graph looks like the blue curve on the right-hand side of your screen. Again, it has a starting point. It rises kind of steeply, but you can see it's starting to level out, going forever in that positive x direction, and it's always going up. So we make a table, and I know I didn't do this one by hand, I will the next example, but we make a table starting from that domain point. Now we have some x's and y's, and now we can tell the range. The range, it looks like y, since x has to start at -4 thirds, y starts at 0 and goes up forever, meaning that y is greater than or equal to 0. That is our range. So we look at this, and the pattern we want to follow is find the domain algebraically, make a table, make your graph, and that will allow you to see the range. Also, just as a kind of a side note, since they do ask about the x and y intercepts, the x-intercept is where y equals 0. So it just so happens that that was our -4 thirds point. That won't always happen, but on this problem it did. And then our y-intercept is when we plug in 0 for x. There we go. So let's start another problem here, and it's going to be this problem. Y equals the square root of 5x minus 7 plus 2. And I'm going to give us a little bit more room. So we need to find the domain, then we need to graph it, then we need to find the range. Let's start this one off. To find the domain, we said take whatever is under that square root, whatever is under the radical, and say that it cannot be negative. It has to be greater than or equal to 0. So that means that 5x needs to be greater than or equal to 7. Once I add the 7 over, x is greater than or equal to 7/5. Domain, x is greater than or equal to 7/5. So 7/5 is going to be my starting point in my table. 7/5. And then after that starting point, I know x's need to be greater than that. So I might pull out my calculator and say, okay, 7/5 is 1.4. So if I want x is greater than that, maybe I'll try 2 and 3 and 4 and kind of get some nice numbers here. So 7/5, let's see what y value we get if we plug in 7/5. I'm going to store 7/5 in my x variable. We've seen this before. And then I'm going to type out my function. Square root of 5x minus 7. And then outside that square root, outside that radical, plus 2. And it tells me when I plug in 7/5, I get 2. What if I plugged in 2? 2 store x. Do that again. And I get 3.73-ish. 73, was it 20, I think? 21 if we round it. Okay. And we could plug in 3. And really, the biggest thing we need to know is it going up or down? Because we know it's going to go up or down steeply at first and then level out. 4.8284. So it sure looks like it's going up. And then let's plug 4 in. 5.6056. Now, quick side note, just to remind you guys, there's nothing wrong with plugging in by hand. There's nothing wrong with manually plugging in a calculator. But there's another way we could do this. We could go to y equals, type in our function, 5x minus 7 under the radical plus 2. And not only will it give us a graph, we can go second table and see our values in the table. You'll notice there are a lot of errors. That's where it doesn't exist because it's not part of the domain. But then at 2, 3.7321. At 3, 4.8284, just like our table. So we can get the table from the calculator. I have no problem with you doing that. If I sketch out this graph, we'll call that good and that good. So 7/5 is 1.4, we said. It's about 2. 2 got us up to 3.7-ish. We'll call it right there. 3 got us up to 4.8. 4 got us up to 5.6. And the shape of the graph is starting to become clear. It's starting to show that it's going to level out, just like we saw on the calculator when I graphed it. Okay, so we have the domain, we have the sketch of the graph. Next question, what is the range? Well, what y values do you see? Y is starting here and going up forever. So it's starting at 2 and going up forever, y greater than or equal to 2. And this is how we can graph and find domain and range of a square root function. So I want you to try this next one and try it with your calculator, try experimenting and see if you can efficiently get this one as well. Graphing y equals negative root 6 minus x minus 3. So pause your video, work this one out, and then unpause it, and I will kind of talk through my work at that point. All right, so on the screen you can see my work. I started off with the domain, set 6 minus x greater than or equal to 0, solved, and saw that x is less than or equal to 6. Guys, note that in my work, I did divide by a negative, which is what flipped the inequality sign. So x is less than or equal to 6. Start your table at 6. I personally just used my calculator to find those values on my table. So 6 was -3, 5 was -4, 4 was -4.4-ish. So I got those from my table. I then graphed. You can see the sketch of my graph over there on the right. And then I looked at it and said, well, I'm going down forever, starting at -3. So y is less than or equal to -3. And just as confirmation, my sketch looks like it matches my graphing calculator. So this is the basic nuts and bolts of how we will graph square root functions. Now I got one more thing for you, but it's a pretty natural extension. How do we graph radical inequalities? Radical, remember, is the official name for that square root symbol because it's not always a square root, as we will soon see. But graphing radical inequalities, here's how we're going to do it. Note that there's no domain and range here. We don't talk about domain and range with inequalities as much. So we're going to say y is less than root 2x minus 6. I need to graph it. So I do need to find my starting point. So I'm going to use the same trick we did with the domain and say that 2x minus 6 is greater than or equal to 0, 2x is greater than or equal to 6, x is greater than or equal to 3. That lets me know where to start my table. X is 3. Coming over here, square root of 2 times 3, and then minus 6 gives us 0. 3 is 0. What about 4? I could also use the x trick here, just showing you lots of different ways we could do this. 4 store in x, and then say evaluate 2x minus 6, 1.4142. Sorry, my keyboard keeps coming up. 5, I'll show you how we can just do this by hand too if we don't have a calculator. Square root of 2 times 5 minus 6 equals root 10 minus 6, root 4, and we'll call that 2 because we're only taking the positive version. So how do we graph this inequality? I'm going to draw my axes. Just about like that. And I'm going to say 3 was 0. Sorry, that's 0, 3. 3 was 0. 4 was 1.4. 5 was 2. And if you're wondering why I was not filling those dots in, it's because I saw this is a less than. Guys, we've done this so many times already this year now. It's a less than, meaning a dotted or dashed line, and we're not really including those points. So less than is a dashed line, and should I shade above or below a less than? Probably below, less than. Now notice where I'm going to shade this. I'm going to shade, shade, it goes on forever, but not in this direction. I'm only going to shade until that starting point there, because that's the only place this inequality exists. Right? It doesn't exist to the left of that point, so I'm not going to go past the left of my starting point. So this is how we graph inequalities, radical inequalities. Find the domain, make your table, sketch it out, and just ask yourself, dashed line, solid line, or shade below, shade above? Which one, which combination of those do we need? So to finish things up, I want you, once again, to just solve this problem. Graph the inequality y is greater than or equal to root 2x plus 4 minus 1. Pause your video. I'm going to pause mine, and then we'll just wrap this up at the end. So here we are with what mine is looking like. Y is greater than or equal to root 2x plus 4 minus 1. So took the radicand, set it greater than or equal to 0, solved for x. X is greater than or equal to -2. Made my table with values greater than or equal to -2, and I could see from those y coordinates it is going up. It does have that steep and then starting to level off distinctive shape that we associate with square root functions. And then since this was a greater than or equal to, closed dots, solid line, shade above. So hopefully this overview of graphing radical functions, radical inequalities was helpful. Rewatch an example if you need it. If you have a question, let me know. Work on those practice problems, and if you're not sure of how to do one, either get in touch with me or circle it so that you can ask about it, homework questions, next time we have class. But guys, that is all for today. I will see you next time.